Hi everyone, my name is Yuan, a PhD student from Tianjin University. It is my great honor to make this presentation and share my research to you. The title of my presentation is Assessment of Natural Ventilation on Thermal Comfort and Energy Consumption. And I will use a case study to introduce the natural ventilation design in shopping malls of the tropics. Firstly is the background. According to the statistical data, in the past few years, there were a large number of shopping malls being built every year. However, behind the booming construction, retail buildings recorded the highest UI among all commercial buildings. If you have been to Singapore, you will notice that the natural ventilation design is a popular design choice of architects. And of course, it also appears in shopping malls. However, due to the building characteristics, its suitability has not been proven. For the public areas, it is continuously occupied by consumers to roam in the building through the entire shopping process. So it is difficult to guarantee the thermal comfort by mainly relying on natural ventilation. For retail stores, managers prefer to adopt the open storefront to reduce the psychological barrier of consumers to come in, resulting in continuous air exchange between stores and the walkways. So here is another question: how to reduce the energy consumption in stores when introducing natural ventilation? For these questions, I selected an interesting case in Singapore and carried out some comparative analysis. This is the building, Westgate Mall. The whole building is divided into two parts: the courtyard, natural ventilated part, and the conventional closed indoor part. Since it was opened, there were lots of complaints. The shop tenants of the outdoor part always complained about their energy consumption being much higher than that of the indoor part. And the customers also want to stay indoors when it is hot outside. To solve the existing problems, I propose the 4 ventilation schemes. The first one is the original scheme, which is used as the base model in this study. The second one is the conventional closed scheme without natural ventilation. The third one is the open scheme with fully natural ventilation. The indoor part in the northeast is also opened as a semi-outdoor space. The fourth scheme is similar to the third one. The difference is that there are air curtains at the entrance of all shops to reduce the air exchange. For these 4 schemes, 2 analyses were performed. The first one is the CFD simulation in Phoenix. The incoming wind was modeled using the maximum mean Wensley wind speed. The second is the energy simulation in N+. The details of the modeling are listed here. For the evaluation, both thermal comfort and energy consumption were assessed. The wind-generated comfort is calculated for the possibility of wind velocity exceeding the threshold of 5 meters per second. The thermal comfort for air temperature is calculated about the discomfort hours using the acceptable temperature range for semi-outdoor spaces of Singapore. For the energy consumption, the energy use intensity was used. Okay, now let's take a look at the results. First is the wind velocity. This analysis is mainly for alternative A, C, and D, which contain the semi-outdoor spaces. The figure shows the CFD simulation results in the highest floor area. It can be seen that even under the condition of the maximum monthly wind speed, there is no area exceeding the threshold. Moreover, by incorporating more open spaces, the wind environment of alternative C and D is obviously improved, which is beneficial for building to make full use of the natural ventilation. The analysis of discomfort hours is for the circulation space in the highest floor. According to the results, obviously, Alternative B, all spaces with HVAC systems has the least discomfort hours. For the other three natural ventilated schemes, Alternative C and D, with more open spaces, have less discomfort hours than Alternative A because of the better ventilation effect. In addition, coating by the air curtains, there is a slight difference between the C and D. Let's look at the energy consumption. Alternative D, the open scheme with air curtains, is the most energy efficient solution. For Alternative B, although it can reduce the cooling energy cost, there is a significant increase of the energy for mechanical ventilations. We also present the simulation results of cooling energy cost in different thermal zones. Continuous air exchange can result in the cooling energy cost in outdoor shops being nearly 4 times that of the indoor ones. Through comparison, it is also found that better ventilation can obviously decrease the cooling energy cost. Lastly, the air curtain is an effective method for shops to reduce the air exchange. Finally, here are the conclusions. To summarize, when being carefully designed, the natural ventilation won't hurt the thermal comfort. On the contrary, it can significantly reduce the building energy consumption. Additionally, by incorporating more semi-outdoor spaces, it will provide a more holistic shopping experience for consumers. Okay, that's all.